before class started, just so we can kind of review the process with using the chain rule. So remember, we use the chain rule when we have like this inside and outside function. So if I'm looking at this problem, we have y is equal to the tangent of 1 over x. So we do clearly have kind of like this inside function and an outside function, where 1 over x is the inside. I also chose this one for a reason, because there's many of you on your last quiz that kept wanting to do the quotient rule over and over and over again, even though that does waste time. So before I even find the derivative of this one, I would suggest rewriting it as tangent of x to the negative 1. We can rewrite 1 over x as x to the negative first power. And then I can easily find the derivative. So remember, when we take the derivative using the chain rule, you take the derivative of the outside function first. The derivative of tangent is secant. The inside function remains the same, and then you multiply it by the derivative of the inside. So the derivative of this inside, negative 1 comes down in front, and then subtract by 1 in the exponent. If you want to clean this one up and write it a little bit differently, we would have the secant squared of 1 over x, and I'm just going to move this coefficient to the front, of negative, and this is times 1 over x squared. So again, this idea behind the chain rule, we're taking the derivative of the outside, leaving the inside the same, and then multiplying it by the derivative of the inside. If you end up having like multiple insides, you just kind of keep linking those together with multiplication. This second one we could do with or without the chain rule. I can kind of show us two different ways to do it. If I'm doing it with the chain rule, we can see it's the chain rule because we have this inside function of 4x squared, and it's raised to the 1/3 power. So using the chain rule, what is y prime going to be? That outside function is something to the 3rd power, so I can move the 1/3 down in front. 1/3 minus 1 is negative 2/3. Leave the inside the same, and then we can multiply by the derivative of the inside. And the derivative of the inside would just be 8x. If you wanted to clean this up a bit, you could, but that would be the derivative that we're looking at. This is one case where you could avoid the chain rule just because there's like no plus or minus signs here. And if you want to avoid the chain rule, you can just think of this as a coefficient of 4 times x to the 2/3. So taking your derivative, 2/3 comes down in front. That original coefficient stays. And then x to the negative 1/3, 2/3 minus 1 would give you that answer. I know those two answers look very, very different, but they actually are equivalent and the same. So there are some cases where you can kind of avoid having to do the chain rule. That is one case where you can avoid the chain rule by kind of rewriting it using some exponent properties. But most of the time, like in this first one, we're not going to be able to rewrite it, and you are going to have to use the chain rule. Any questions on those two problems?
No.
So looking at what I really wanted to focus on today is with the second derivative. So up until this point, we haven't really spent much time like finding the second derivative. So we know that the second derivative does relate to things like the concavity of the function, how it's bending, and things like that. Well, you actually can find the second derivative algebraically. And how do you find the second derivative algebraically is you have to find the first derivative first. And then once you find the first derivative, you take its derivative, and that gives you the second derivative. So let's just go ahead and find the first derivative for this one. If it helps you think about it a little bit differently, this is sine squared. So you can think of this as the sine of 3x, and then all of it squared. So this is the one that's going to be like the two chains rule. You're going to do the chain rule twice when you're taking the derivative. On the very outside, we have something squared. Inside the squared is the sine function, and then inside the sine function is the 3x. I'm going to find the first derivative. I'll try to color code everything. The outside function is squared, so 2 comes down in front. The new exponent is a 1. We cannot touch the inside yet, so we still have the sine of 3x. And then by the chain rule, we want to multiply by the derivative of the inside. So the derivative of the inside is a sine. The derivative of sine is cosine. Can't touch its inside, so that's going to be the cosine of 3x. And then times the derivative of cosine's inside is 3x, so we're going to multiply it by 3. So that is the first derivative. To find the second derivative, we want to take the derivative of this expression. Before I find the second derivative, I do think it makes sense to simplify this because a simplified function is going to give us an easier derivative. So if I'm simplifying this, the 2 times 3 is a 6, and I can drop that first power on the sign. And so this is my first derivative. So now if I want to find the second derivative, I just need to make sure I use my rules correctly. Using my second derivative for this one, I can kind of see that this is a sine times cosine, so I'm going to have to use the product rule. And I'm just going to split it up and think of this as a 6 sine of 3x and then a cosine of 3x. So we are going to have to use the product rule. And inside of that product rule, the chain rule will be showing up as well because we see a sine of 3x and a cosine of 3x. So using my product rule, I have the first times the derivative of the second, the derivative of cosine inside stays the same, and here's the chain rule. What's the derivative of the inside is a 3. And then plus, so that was the first times the second, so then I have the second one times the derivative of the first. And the derivative of the first, I have a 6, that's a coefficient there. The derivative of sine is cosine, inside stays the same, times the derivative of the inside, which is 3. You can simplify this a little bit. So I have like coefficient 6 times 3, which is 18. And it's going to be a negative. Sine times sine is sine squared of 3x. And then plus a cosine times a cosine is cosine squared of 3x. Also have coefficients of 6 times 3. And so there is your second derivative of that problem. We won't spend too much time like actually doing stuff with the second derivative in this unit. We're going to save that for unit 3, where we'll actually be able to use the first and the second derivative to kind of draw accurate graphs of these functions and be able to interpret them a little bit better. Were there any questions on how I found that second derivative? All right, so I told you today's notes were going to be short. That's all I need to get done today. Your assignment, I'm leaving you with the same thing that I kind of left you with yesterday. So homeworks numbers 1 through 6 were all done or hopefully already done. If you haven't finished those, then you can definitely get those finished before your test. There is the chain rule homework. It is posted in OneNote. I didn't realize, someone let me know that I did leave off the last page. So it's like the last 3 questions. If you are looking for those last 3 questions, I posted that page into the content library of OneNote, or I also just texted it out via Remind yesterday afternoon. Normally I would just say don't worry about them, but I did choose those 3 problems for a reason, because they do have some good types of problems that I need for you to review for those topics. So the chain rule homework, again, you're doing multiples of 4 for all of those sections, so it doesn't end up being as much as it looks. Some of them do algebra just because the chain rule just by nature sometimes has a lot of algebra in it. Next week we will be returning, as far as I know, to full face-to-face. The superintendent still has until Monday technically to make his decision. But when we do go to full face-to-face, again, I'm assuming that's going to be on Wednesday. We will be going back to the regular bell schedule for the most part. So this class will be meeting forever long at the very end of the day until 3:30. I will send out the actual bell schedule via Remind this afternoon, because there are some changes, like we have to have lunches spaced out a little bit more and things like that. But just know that this URL schedule is going away. So I'm going to leave you with that. If you want to stay in the meeting and ask questions about any of the homework, definitely do that. If you rather just go ahead and sign out and work on the homework on your own, that's fine. Or I guess if you're at home, you can technically just start your weekend. I do want you to have a good weekend, so don't try to do too much homework over the weekend, because again, we will have all class time Wednesday and Thursday to get stuff done. So yeah, that's it. Have a good weekend. And again, feel free to hang back in this meeting if you do have any questions.